In this video, we're going to be talking about data presentation and more specifically about frequency distribution tables. So here I have a quote about Lewis Carroll. I was telling you that once you have a lot of data, you need to make sense of the data, right? So you need to make sense of it for people to understand the data and they are able to make important decisions. So it says, the question is, said Alice, whether you can make words mean so many different things. The question is, said Humpty Dumpty, which is to be master, that's all. So that means that when we have numbers, we can make them mean so many things, and we want to be very honest about what we're saying with those numbers. So data presentation makes us see the numbers in better ways. Frequency distributions are a way to present data when we have a lot of it. So it shows the frequency. The frequency, remember, is the time that something occurred. In each of several categories, frequency distributions are used to summarize large volumes of data values. When raw data is measured on a quantitative scale, either interval or ratio, categories or classes must be designed for the data values before a frequency distribution can be formulated. So what is a frequency distribution table? Let me show it to you before we go to the steps. You might have seen some tables like this. So this is what we're talking about. We have 33 data values, and instead of seeing the list of the 33 data values, we have already presented it like this in a table. Okay, so let's see how we can construct a table like this. So what do we need to do to construct a frequency distribution? The first thing that we need to do is to determine the number of classes. The number of classes are how many rows I'm having to present my data. So it is not always just saying from 0 to 10 and from 11 to 20. We can do two things. We can either follow Sturge's rule, or the problem can tell you how many classes you are working with. So Sturge's rule, C is the number of classes, and it is a mathematical formula that it's 1 plus 3.322 log of n. N is the number of data points or of data points that you have. So that's the first thing that we do. Then you need to determine the size of each class. And the size of each class, or the height, is going to be their range over the number of classes. The range is the upper value minus your lowest value. Then you determine the starting point for the first class. This is usually your lower value. Then you count the number of values that occur in each class. So for example, if we had, 10, 11, 13, 14, 15, 13, 11, 12, and my class is from 10 to 12, I know that I have the 10, the 11, and the 12. So my frequency was of 4. So I need to count those numbers. Class mark is the midpoint value of each class length. So for example, in this example that I have, if my class goes from 10 to 12, my class mark is 11. It is the midpoint of my class. And then we need to prepare a table using the actual counts or the percentages. So in a frequency table, we can have absolute frequency, that it's actually the number of occurrences or we can have the relative frequency, which is the percentage of the occurrences. Here we would have the absolute over the total number of occurrences. The cumulative is a way to show the total numbers that lie above or below. In a cumulative, we're going to be counting how many we have so far. We can have cumulative frequency or cumulative relative frequency. So let's see what we have here. So in this case, we have 6 classes. My lower limit was 35.5 and my upper limit was 105.5. Between those, I separated this in classes. So if you can see here, I go from a 35.5 to a 46.5. The midpoint is going to be 41. So how many times did a number fall between the 35.5 and the 46? 2 times. What is the relative frequency? So what is the percentage of 2? So it will be 2 divided over 33 times 100. It gives us 6.06%. So in my other class, I had 5 times where a number fell between the 46 and the 57.5. My class mark, my midpoint, it's going to be a 52. And if I want to change the 5 into a percentage, 5 over 33, that is my total, times 100, I get 15%. So that's how you would be constructing it. Now, what is the absolute? The absolute is just adding them. So for example, here I started with 2. This number is the same as this, but this 7 is the 2 plus the 5. So the 2 plus the 5 gives me a 7. And the 7 plus the 5 gives me a 12. And the 12 plus the 7 gives me 19. 19 plus 9 gives me 29. And 29 plus 5 gives me the 33. This should be my total n. In percentages, it's easier because it needs to add up to 100%. So let's see what is it that we have here. Let me erase. So for the cumulative in percentage, we start with 6. So 6 plus 15 gives me a 21. 21 plus 15 gives me a 36. 36 plus 21 gives me a 58. 58 plus 27 gives me an 85. And 85 plus 15 gives me around 100%. So that these 2 tables are accumulating. One of the things that we can do when we have group data in a frequency table is getting the mean. So remember that the average number is always a very important number. So in this case, we want to know the mean, and we do not have the raw data. We already have a frequency distribution table. So it says the following table gives the frequency distribution of the number of orders received each day during the past 50 days at the office of a mail order company. Calculate the mean. So it says we have between 10 and 12 orders, we have 4. Between 13 and 15 orders, we have 12. Between 16 and 18 orders, we have 20. And between 19 and 21 orders, we have 14. And my total is 50 orders. Okay, so this is what we're going to do. We're going to get the class mark. If you see, the class mark is the midpoint of this, so it will give me 11. The midpoint of this gives me 14. This gives me a 17, and this gives me a 20. And the class mark, I'm going to multiply it by the frequency, and that gives me a 44. 12 times 14 gives me 168. 20 times 17 gives me 340, and 14 times 20 gives me 280. And I'm going to add them all. Once I add them all, I divide them by my total number, and it gives me the mean, 16.4. And that makes a lot of sense because if you see in my frequency distribution table, the most orders are in this bracket. So it makes sense that the mean is somewhere between this bracket because that's where I have my most orders. So how can I interpret this? This means that most likely I will have 16.4 orders.